Welcome to Conditional Statements. We're going to start with equivalence or biconditional. And this is represented by this symbol with two arrowheads. And this means that when two statements are either true together or false together. Okay, so let's look at the truth table for equivalence. Okay, so when your statements or propositions are both true, you get the value of true for biconditional or equivalence. The same way when both of your statements or propositions are both false, that's when you're going to get the value true. Okay, so when they're different, like true or false, or true and false, then false and true, you get the false value. Okay, so note, this symbol for equivalence is read as if and only if. We already discussed this when we did logically equivalent. Okay, there are two ways to determine equivalence. The first method is to construct a truth table, then compare the final two columns. If the values of your last entries are all the same, then the statements are equivalent. The second method is that you construct a truth table for two statements with extra column for the biconditional. And you'll know the values of the biconditionals because I have shown you in the first slide the values for biconditional. If the biconditional column shows a tautology, then the statements are equivalent. Okay, so let's try them both. Let's do method 1, and we're going to fill out this table or complete this table. So we have here the values of the proposition P and the values here of proposition Q. Let's negate P first. So we'll have all the opposite values of this column. Starting from the first one, you'll have false. You go to the second one. The second one is true. It's false. You go to the third one. It's true. The last one is true. Okay. Then the fourth column, let's negate proposition Q. Starting from true, you'll have false. Then you'll have true. And then false, true. Okay, now we're going to compare P and the negation of Q. So this first column and the fourth column. Okay, and we're using AND. So true and false is going to be false. True and true, this time it's not false, but it's true. Okay, false and false is still false. False and true is false. Okay, now after doing this column, let's do negative, the negation of P and Q. So you have this column, negation of P and Q. Okay, so I'm going to put my pointer here in the middle. So false and true is false. And then false and false is true. True and true is true. True and false is false. Okay, now let's combine these long compound statements. Okay, so this math notation is this column, and then this notation is this column, and we're doing inclusive OR. Okay, so I'm going to put my pointer in the middle. False or inclusive disjunction, false. You'll have false. Okay. True and true or false is true. False and true. False and true here is true. And then false and false is false. Okay. Now, let's have a simpler. Okay. compound statement P, but this time it's an exclusive disjunction Q. So we will read this as P or Q. So for true and true, you'll have false. For true and false, true or false, we have true. False or true is still true, and false or false is false. Now, if we take a look at the last entries of both tables, you have FTTF here, and then the last entry of this column or this table, the last entries, they're the same, FTTF, so we can say that these two are logically equivalent or equivalent. Okay, so they are equivalent. Okay, let's look at method 2. Method 2. Okay, so if you have a table and this is a long one, this is the same as what we did. I just use, okay, I wrote the values here, FTTF, FTTF, I combine them together. This is from the first slide. And then I use the biconditional, okay, to get the truth value for the last entry. So I'm using this. If you go back, it's our second slide after the title. You will find all the values for biconditional. And when you go and do F false and false, you'll have true. True, 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 true is true. Okay, false and false, true. So looking at the last entry, they are all true. It's a tautology. So then it's equivalent. Okay, so you can do the equivalent, the biconditional tests to find whether they're equivalent or not. Okay, now for 3 conditional statements, if you have R, if you're going to have the proposition R, okay, for 3 conditional, this can happen. You may have a converse, and a converse is when you have Q, okay, this is if Q, then P. Okay, remember when we have this symbol, this is an argument. Okay, we use this in implication. So you can go back to the implication video and you will see the symbol. Okay, it's a converse if Q, then P. It's an inverse, okay, if it's the negation, if the negation of P, then negation of Q. Now in here, it's important, the order of your proposition is important. So you have to take a look at the order of your proposition. Okay, it's contrapositive when this is the case, if negation of Q, then negation of P. So these are your additional conditional statements. Okay, this will be the last. Okay, so let's have an example. Your propositions are proposition P, it is raining. Proposition Q, I will get wet. Okay, following what I have given you, the formats that I have given you. For converse, okay, if Q, then P, then you will have if it's raining, then I will get wet. Okay. The next conditional statement is an inverse if it's the negation of, if negation of P, then negation of Q. Okay, so if it isn't raining, then I won't get wet. It's contrapositive when you have the negation of Q, if negation of Q, then negation of P. So contrapositive is I'm not wet, then it isn't raining. Let's have the truth table for direct argument. This is if then. So for your statement, then your converse, inverse, and contrapositive. Okay, so if given the values T and T, it's a statement, it's still true. Okay, so all the way until contrapositive, it's true. Okay, false and false for direct argument, you will have true all the way from statement, converse, inverse, and contrapositive, they're all true. Okay, now it gets confusing when you get to here. Okay, when you have true and false value, okay, you will have false here, true, true, and false. Okay, on the other hand, if the first one, if P is false followed by T, then you will have T for true for statement and contrapositive, but you will have false values for converse and inverse. Okay, so given that, direct argument and contrapositive are logically equivalent. These are these values, T, F, T, T, that's your direct argument, and then your contrapositive is T, F, T, T. Since they have the same values, then they are logically equivalent. Okay. So, it's important, this is our last video for this unit. So may I remind you to please practice, practice, and practice, and more practice. Okay. Good luck, grade 12, for your test.